I am Poh Lok Yee, and this is my presentation for the Data Mining Project 1 and 2 summary and also the reflection. So let's begin. In Project 1, we focus in a real-world healthcare issue, which is to predicting the heart diseases. That's why our title for Project 1 is Heart Failure Prediction. Our goal was to build a model that could help doctors to make faster and also more accurate decisions based on the patient data. We work with a dataset which have 900 plus patient records and also 12 features in it. For this task, we have applied the KNN, K nearest neighbor, and also the NAF-based method to classify whether a patient likely had heart disease or not. Before building the models, we process the data first by starting with data cleaning. We handle the missing values and encode the categorical variables, and we normalize the numerical values so that it's easier for us later on apply in the KN methods. Later on, we split the dataset into training and also the testing models, and we can get that the KNN have the accuracy of 86.96% and NIF Bayes got 87.32% of accuracy, and both of them have strong F1 scores. This shows that both models were reliable. For the Project 1, we can know that the KNN is effective for the binary classifications in predicting the outcomes, and the NAF Bayes can assist in the risk stratifications for healthcare professionals. What it means that the NAF Bayes can help us to classify the patient into low, medium, or high risk groups. Both models can enhance the decision makings in healthcare scenarios and interventions. That means that this model can support the real medical decision making, especially in helping healthcare providers in identify high-risk patients early. Then in Project 2, we explore how unsupervised learning could be used in the education field. Our aim was to group the student based on the behavior and also their academic traits. So our topic for our Project 2 is clustering student profiles for academic insights. We work with a dataset that contains 2,000 plus patient records and also including 15 features in it. To uncover the hidden patterns, we use the K-means method and also the hierarchical clustering to find out the patterns of the students. To start, we also do the same thing in Project 1. We clean and normalize the data by dropping the irrelevant ID columns and also normalize the GPA, absence, and study time. So for the K-means model, we have used the elbow method to identify that 4 clusters were optimal for K-means model, while for the hierarchical method, we have used the agglomerative method with the word linkage to apply on it. And we do have the dendrograms to clearly show out the natural separation into 4 clusters. We do have a silhouette result score for both models to do the comparison. For the K-means one, it just achieved 0.168, while the hierarchical method is achieved the 0.546. That was quietly higher than the K-means. This means that hierarchical method will have a better performance and will give us a clearer and more meaningful student groups compared to K-means. From the key insights of the Project 2, we can see from the clustering result, we have found the 4 distinct student groups. These profiles can help schools to design the target interventions, such as academic mentoring for the student in Cluster 3 or the leadership program for those in Cluster 4. This clustering gave us a deeper understanding of student behavior beyond what grades alone can show. For my overall reflection, looking on both of these projects really helped me to understand the data mining course in a deeper level. Before this, I mostly just knew about the theory, but throughout this hands-on experience, I was able to apply those concepts step by step. After understanding the grips, it helps me to enhance my project management and also the execution skills when I'm doing the project. I learned the value of proper data cleaning and the pre-processing, because without a good quality data, even the best model also won't give a reliable result. I also learned the difference between the supervised and unsupervised learning, and I'm able to apply them in real-world situations. Like Project 1, we have used the classification models to make medical prediction. And what stood out the most is I realized how data mining can improve the sectors, can make a real impact in our real life. This course didn't just improve my legal skills, it helps me to improve how I approach the problems, and also motivated me to continue learning more in this field. And that's all for me. Thank you.